Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 4 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got function p here is in the form y equals ax squared plus c. So that's going to be a little bit weird for us. So what do we know about the parent function? Well, your most basic function we call our parent function, y equals x squared. When we're looking at this quadratic, what we get here is we get a perfect parabola. It's opening up. Vertex is right there in the origin, the 0, 0. So we've got two things happening here. We've got a multiplier in front of that x, and then we have an addend here. We're adding to that c. So what happens to those things? Well, let's talk about the a first. So if the a is less than 0, which they want us to be right here, when the a is less than 0, that means it's negative. What it actually does is it flips or reflects our graph along the x-axis. So it reflects down. So it, instead of facing up, it faces down. If the a happens to be between 0 and 1, then what happens is it becomes wider, but it's still facing up. And if a happens to be greater than 1, it becomes narrower. It becomes very, very skinny, still facing up. So this reflects down. If it's less than 0, the other two still are going to face up. So since a is supposed to be less than 0, right, so we can get rid of g because that's facing up. It's going to be reflecting down. Now what about this plus c? Well, when you have it in that form right there, and it's not standard form, so standard form has got this right here, bx plus c. That b right there will affect the vertex as well, but when that's out of the picture, it's just ax squared plus c. This just moves it up or down the y-intercept or the vertex, depending on which we're dealing with. In this case, those two are going to be the same because it's not shifted to the left or right. So what the c does is it moves it up or down. So if the c is greater than 0, it literally just translates it up. And if the c is less than 0, it just translates it down. So greater than 0 moves it up to the positive, less than 0 moves it down to the negative. So it can only be f, h, or j, but take a look here. F actually moves it up a little bit from the origin up. So this has got a c that is greater than 0. And look at this j. It's still at the origin, which means the c equals 0. I didn't move it anywhere. So I'm thinking it's h because that c is less than 0 because look, it went from the origin, it went down. So let's actually see if we can test this out. What I want to do is we're just going to just play with numbers a little bit, and let's see if we can say y equals, they both need to be less than 0. So let's say negative 2 x squared minus 2. Let's make a and c both equal negative 2. Let's graph it and see if we can get something similar to h. So we're going to go into this y equals here. And if we want, we can go ahead and just keep or put the parent function in there just so we can see what that looks like. Right? That's your basic parabola. Now let's go back and let's add, what did we say? We were going to do negative 2x squared minus 2. And let's just see what happens. What is the difference here? And so we want that to be 2. And if we graph that, look, it flips it upside down, and it moves it down. Now, it only moves down 2. It looks like right here it might be a minus 4. Right? So if we were to go back and change that to a minus 4, and we might be able to get a little bit closer. And there we go. Yes, it moves down a little bit farther. So our answer here is going to be H.